Hello friends, in this video we will discuss the concept of recursion. Recursion is an important concept in programming because it helps in implementing complex algorithms with ease. Because writing an algorithm for recursion is easy as compared to implementing the same thing using stacks and a loop in a programming language. Recursion was the first compiler that implemented recursion was developed by Dijkstra, and recursion is a mathematical concept which has been implemented and brought into the programming languages. Now, what is recursion? In mathematics and in computer science, what we do is we define the task in its own terms. That means there is a function which calls itself again and again. Now, when the function will call itself again and again and perform the same set of operations, now what is the catch here? The catch is that we have to define a base case. That is when the function will not call itself and return a simple value. And we have to define that when the base case is not called and we are calling the function again and again, some value should change in such a manner so that we become closer to the base case each time the recursion is invoked. So there are two things. One is the base case should be clearly defined, and the second is that all other cases should reduce towards the base case. Let us understand this better with the help of an example. Now here I have a simple function, a function f. What it is going to do is, if the value of x argument is equal to 0, I will simply return 1. So this is the base case, that if the value of x is 0, I will simply return 1. But if it is not 0, then what I am going to do is, I am going to calculate 2 into f of x minus 1. That means I am going to call the function f again with the argument x minus 1. So this is the reduction towards the base case where I am invoking the main function again with an argument which will take me closer to the base case. And then we return the value of y plus 1. So basically this is an implementation of a recurrence relation in which we are calculating t of n. And how t of n is defined? It is defined as 2 into t of n minus 1 plus 1. So, and the base case is that t of 0 is equal to 1. So this particular function, it is going to solve for this recurrence relation. So initially, if we call the function with the help of the x is equal to 3 value, then we have to calculate the value of y. So we will call f with 2 as the argument. Why? Because first we will come here x is equal to 3. Now we will come here 3 is equal to 0. So it is not true. So we go to the else part. And here we make a call 2 into f of 3 minus 1, 2. So we are going to call f of 2. So within the main call which has been executed just now, we are going to put this main call on the stack and we will make a fresh call with x is equal to 2. Again we have to calculate the value of y and we will make a fresh call to f is equal to 1. Still the base case is not met, so again we will push this call with x is equal to 2 also on the stack and we will call the function with x is equal to 1. Now when we call x is equal to 1, again we will try to call for f is equal to x is equal to 0. So now this base case is met and we are going to return the value of 1. So when we return the value of 1 from here, now this x is equal to 1 is going to receive this value and we will perform 2 into 1 is equal to 2 and plus 1 3. Then we will return this value to x is equal to 2. So we will get 2 into 3 which is 6 plus 1 7. And then to the main calling function where x is equal to 3 was there. And here we will perform 2 into 7 is equal to 14. And then 14 plus 1 is equal to 15, and that is the final value which is returned by this particular function. So first we go into the depth till the base case is met, and when the base case is met we come back one step until the time the final answer is generated. I hope this video is useful to you. Thank you very much.